In this video, we'll go over how we can use various graphical displays to help us assess the various assumptions in a linear regression setting. So we'll specifically look at a simple linear regression setting here. So the assumptions are, right, that it exists a linear relation between the response and the predictor variable. The error terms have mean zero. They have constant variance, the errors are uncorrelated, and the errors follow normal distribution. So we'll talk about how we can assess each of these assumptions using various graphical displays. So for the first three assumptions, we could use a scatter plot of the y variable against the x variable, or a residual plot of the residuals against the fitted values to assess the first three assumptions. Now, I would say that in a simple linear regression setting, you can use both of these. In a multiple linear regression setting later on, right, you can only use the residual plot. So the first three assumptions, right, are that there's a linear relationship, the average value of the errors are zero, and that the errors have a constant variance, right? So the errors are the values in the population. So what we'll do is we'll look at a residual plot. So residual is the sample version of the errors. So we could use either the scatter plot or the residual plot. So what features are we looking for in these settings? So if you're looking at a scatter plot of the y variable against the x variable, you want to see whether the general pattern is a straight line, right? So obviously you don't want to see a curved pattern. The data points should be evenly scattered around the fitted line. So if you look at your fitted line, the data points should be scattered on both sides of the fitted line for the average to be zero, for the average of the errors to be zero. And the vertical variance, right? So the vertical distance of your data points should be constant. For the residual plot, basically, we are looking for these features. The residuals are evenly scattered around the horizontal axis with no pattern, and that they should have similar vertical variation across the vertical axis. So in a residual plot, what we are looking for typically is a situation where the residuals, some people will say that they fall mostly in a horizontal band, right? So this mostly in a horizontal band, right? So they're evenly scattered across the horizontal axis, no pattern, and the vertical spread is basically the same as one moves from left to right. So we'll look at a couple of real-life examples, right, just to show when these assumptions are not met. So this is a scatter plot of the price of used Mazdas against the age of the car. So the first feature is, do we have a straight line relationship? That can be a little bit difficult to tell. It kind of looks a little curved, right? Over here, all these data points on one side of the regression line. Over here, are mostly on this side, and in the middle portion, they're on the other side over here. And again, for each fixed value of my x variable, right, are the data points evenly scattered on both sides of the line. So in the middle portion, right, they're mostly on the bottom side, whereas over here, all these data points, right, are on the other side of the equation, on the regression line. So they're not evenly scattered, we can kind of see. The last point is the vertical spread. So over here, the vertical spread is pretty large, but as you go from left to right, the vertical spread gets small and small. So you can kind of see, right, that the linear relationship, not really. The data points, I should say, they're not evenly scattered on both sides of the line, and the vertical spread, right, is not constant. So based on this scatter plot, that's not good. We can also look at a residual plot. And in my opinion, actually, a residual plot is a lot easier to look at, right? So thing we want to look, right, is whether the residuals are evenly scattered on both sides of the horizontal axis, and that's not the case, right? These are all positive, mostly negative in the middle, and then for large values, for large fitted values, these are pretty big as well. So that's not evenly scattered on both sides of the line. The other feature we want to look at, vertical spread. So pretty small at first, and then as one moves from left to right, the vertical spread gets larger and larger, right? So that's not what we have. So in my opinion, residual plots are a little bit easier to use, and that's what I recommend.